So those of you who want to follow along, and I hope it's many of you, you can already go to a web page. So open your browsers and go to bit.ly, so bit.ly//WT for hotel -clinic. Or you can type in the GitHub URL directly, github.com/hotel-CDMS-2022-tutorial. Okay, or you just use the shorter bit.ly/WT clinic dash in between. And if all else fails, this material is so wonderful that you'll be seeing, you can do it all on your own. Yeah, it's self-paced. I created here by my colleague, in particular Craig Willis, also Kaspar Kowalik. They're both sort of helping me, assisting me online to the extent I need some hand holding. But you can go there, and also the slides. I'll be starting off with a couple of slides to set the stage and give an overview. Those are also available from that GitHub site. So you go to the GitHub site, there's a link to the slides, you can follow along with the slides, and in particular, we'll do sort of hands-on stuff throughout. And if something, I've noticed this in my own clinics, if something doesn't work on your computer, you're sitting close to somebody who has things working, maybe you can just stick your hands together. Right.
So the slide should be in that bit.ly docs.
Yeah, so I'll go there.
Okay.
I'll just go there. If we click on this here, it will open a repository and the Z accompanying presentation. And then we'll walk through this, yeah, in a moment. But I do start with the slide. The link to the slides is right there. Yeah. So I see some people nodding. If you nod, that's always good. And if you throw your hands in the air, that's also good. Then I know we're going to get some. All right. So why don't I get started? All right. Well, okay. Thank you. And welcome, everyone. I'm going to go put this into presentation mode. And this should take, I don't know, maybe 15 minutes or so. Let's see. So, my name is Bertram Lulischer. I'm a professor at the School of Information Sciences at the University of Illinois in Urbana-Champaign. My accent is originally from Germany. I still carry it with me a little bit. And online, I have two people right now, maybe one later. Craig Willis, who has really led the creation of this wonderful material that I found quite useful. I hope you'll share that view. And Kaspar Kowalik, who's the chief architect of the system that we're going to demonstrate today, the whole-tail system. And the theme of the clinic, the theme of this tutorial is, of course, how can we publish transparent and reproducible computational research with this tool called whole-tail? And I think it'll resonate with some of the things that you've seen in other clinics or also in talks. Earlier on the first day, there was a talk on FAIR software, and I think a little bit on FAIR data. And so I think you'll recognize some of these themes here. Okay, so now I'll try to click through this. This is a little new for me here. So how do I advance to the next slide? How about that? Maybe I need to click here. All right, so okay. So this is the rough plan. So in the first 10 to 25 minutes, I mean, 10 minutes or so for the slides, 15, and then we'll jump into sort of a hands-on part where you'll follow along if you want to. Otherwise, you'll just watch me do stuff. And then we'll create a tail and we'll run things and all of that. And then we'll probably have a short break if you want to get some more cookies or something, or maybe we'll just catch up and then we'll continue. And then at the end, there's time for discussion, Q&A. And then also, I hope to have some time, and there's a link for a survey. We'd love you to fill in the survey for people to give us some feedback on the system. So not so much on this tutorial, although that too, but also, does that relate to your research? Could you use this? What's missing? What's great? What's not so great? Yeah. So that survey link is also available from that same GitHub repository. Again, for those who came a little later, bit.ly/WT-clinic. Is where all of this stuff is available. Okay. All right. So first of all, what is whole-tail? Well, whole-tail is an NSF-funded project, Data Infrastructure Building Blocks or DIBS project, and it's also an open source platform to support computational transparency and reproducibility. You saw that in the title, and maybe that's what brought you also here. It's meant to simplify the process of creating, publishing, and verifying computational research artifacts. Again, I think this was a theme that we heard before. So we call these research artifacts, sometimes they're called research objects, and we'll look a little bit closer into what's in those research objects, but we call them tails. The name originally whole tail is a little bit of a language game. We speak of the long tail of science. We want to empower scientists who are not doing 24/7 computational things. So there's the whole tail. We want to cover the masses, but tail is also a story. So we want to really capture the narrative that goes with a computational workflow, with the analysis and so on. Okay, so let me also try to optimize my screen setup here a little bit so I can in fact read what's there. Okay. All right. So the whole tail system, you will see, we're going to use it in the browser. There's nothing that you need to install on your computer, so it'll run in the browser. But those of you, this community in particular, if you want to run your own instance of whole tail, this is a little bit more for the advanced folks. If say this community, CSDMS, decides to create an instance, you can do that too. Yeah. So you are not tied into or locked into our infrastructure. For convenience, you can use our infrastructure, but please keep in mind, by design, we want the system to be also installed by different communities, so you can do that as well. All right, so if you as community service dynamics modeling systems people want to run an instance, we'd be really happy to help you set it up and you'll run it, and next year we'll all use whole tail. Okay. Oh, the links I should mention, there's the project side. It's easy to remember, wholetail.org. And then the actual sort of interacting with the system is called dashboard.wholetail.org. You can also get there from wholetail.org by clicking on try it. Yeah? So that'll bring you there. Oh, I should mention that we're operating this instance of wholetail on an NSF Jetstream cloud infrastructure. Yeah, so we'll use that today, but again, we're not tied to this. So if you wanted to run it, just do it. That's not going to be part of the clinic though. We are going to use wholetail from a user's perspective, not from a sort of an infrastructure perspective. Now, there's a little bit sometimes of a terminological confusion. What do people mean with reproducibility and replicability and so on? So let's just quickly have a quick look at this. So when in wholetail we talk about reproducibility, what we mean is the narrow sense of computational reproducibility. So here we've adopted the definition of computational reproducibility from the national academies. There was sort of a working group or a committee that came up with a report, I think in 2019. And so the idea is that we try to get consistent results using the same data, the same computational steps, the same methods, the same code, and so on. So you could also call it repeatability. Some people call this actually replicability. Yeah, that's where the confusion arises. But the point is, you have pretty much the same of everything, same code, same, but also same platform. Yeah. So that's what we normally mean by computational reproducibility. Now, sometimes you want to have a more broad notion that's called by this community is called replicability, where you vary things. Maybe you run on, well, you run with different data, different but similar data, or you, of course, have a different set of people running it and maybe on a different platform with a different programming language. Yeah. So when you want to check that your results are reproducible or replicable in the most general sense, it's more than just re-executing one-to-one what somebody has done. Okay. But for our purposes, we are in the business of just re-executing exactly what the authors did when they were publishing a paper. And we want exactly pretty much the same results. And we want to do that in a way that can be verified. Now, occasionally, re-execution is not an option. Why could that be the case? For example, maybe the original execution was using sensitive data, proprietary software. It took hours and hours, weeks and weeks of compute time, and somebody who wants to verify this or redo that, they're in a difficult spot. So the thing that helps us out in such situations is this notion of transparency. So if we are transparent about what we've done and have kept records, we call these records provenance, yeah, then even if we don't re-execute something, we can trust in the results. And this is this notion of computational transparency. Okay, right. Okay, but again, in many cases, we can do something sort of, I don't want to really compare this transparency versus reproducibility, but we can often just re-execute something. It's also going to be the focus today. All right. So we have identified the following core factors that affect computational reproducibility. And this is based on an analysis of reproducibility policies and workflows across peer review outlets in a number of disciplines. And in particular, you see a reference down there in the slides. There's also a slide at the end that has all these references. So Craig Willis, who's created this tutorial, and Victoria Stodden, they have a paper in the Harvard Data Science Review that's also linked here. Trust but verify, how to leverage policies, workflows, and infrastructure to ensure computational reproducibility in publication. Okay, so you can find more there. In fact, I can possibly bring this up. Nah, not now, because I'm in presentation mode, so I can, if you're interested, we can skim that a little later. All right, so Wholetail presents a particular approach to computational reproducibility and transparency. And the platform enables researchers to run their code on an external system, right? So often you will develop your workflows, your analysis, your model runs, maybe on a local system, on your laptop, or on a more powerful computer. But here in Wholetail, the idea is that you can run your code externally. And we capture information when you execute something in the Wholetail environment. We capture information about the computational environment, including details about operating system and versions of software used. Some of you might have noticed in some other clinics, things that should work didn't always work, and this might happen today as well. But I think we've all seen how difficult it is to install software. Even you say, well, git clone this and then anaconda that, and still things break. And so container technology, which is sort of at the heart of this, we're going to look at this, helps with a lot there. All right. Another thing that we of course assume is that these artifacts that we create, these research objects, these tails, that we publish them in a way where they can survive for a while. Yeah. So we're looking at long-term archival initiatives and archives where we can sort of deposit these tails so others can sort of verify the work years from now, not just weeks from now or hours from now. All right, so I've used that term tail a lot, so let's clarify what is a tail. How should we think of it conceptually? So there's a technical version that says, well, it's a zip file that has all these things in it. Well, what is it conceptually? So conceptually, a tail is a research object that contains typically data, either directly or through reference, code, so software, lots of scripts, whatever. The workflow that maybe ties these multiple scripts together, we can sometimes distinguish these levels. Often the narrative, right? There's human explanations that say what it all is. I mean, your LaTeX paper or your Markdown paper might be just part of that. Documentation, the results, of course, and importantly, also the compute environment. The compute environment, often in a way that allows it to be rebuilt. So those in the know, we can think of this as Docker files. Yeah? So the idea then is that the research object itself is also executable. It's not just a passive thing. It's something we can run and we can publish it and we can share it in repositories. The idea is that also in our project, we're trying to be standards-based to the extent that standards exist. We try to honor them. And again, transparency and verifiability is a principle that we try to follow. Okay. So Wholetail has made a few design assumptions. So it's a web-based platform. So it provides access through a web browser to common research IDEs. So if you like Jupyter Notebooks or Jupyter Lab or RStudio, we don't want to force a new IDE down your throat and say, just use this other system and then everything will be wonderful. No, you use your system that you used. But with today's technologies, it's fairly easy to bring these common environments that you already used, bring them up in a browser, and it's sort of seamless. So that's one principle. And of course, these tails, we want to be able to create them. They should be versionable. We should be able to share them among colleagues, maybe collaborate on them, and then also publish them in sort of a persistent form, accessible form. So we use Docker and using a tool called reproducible, some of you might know this, as a way to share these computational environments. We do not require the use of Git, but we also don't preclude it. So if you're familiar with and like to use Git, you can use that sort of independently or orthogonal from the use in Wholetail. And of course, tails are typically associated with peer-reviewed publications, right? I mean, you can create tails for any little side project, but I think this approach shines in particular when you have a publication that has maybe even requirements to share your artifacts. Then this is for many hopefully the way to go. Okay, so before again we come into the hands-on parts. I know I'm showing lots of slides here, but we'll be soon done. So let me give you a high-level overview of how the Wholetail platform works, because it'll set the stage of some of the steps that might seem a little strange that we're doing. So hopefully this will fill in some of the background. So a scientist, researcher here, in order to use the system, will need to, when you want to create a tail, you need to authenticate. Yeah, so you will be authenticated. You'll see this in a moment. You can log in through your basically by rerouting to your institutional ID, so your whatever, University of Colorado or whatever login, Virginia Tech, wherever you guys are from, or you have, if you have a Google account, you can log in with that as well. Yeah? We'll see that, and then you're part of the system. So you authenticate, and then you can access any of these, where's my mouse, any of these common environments, and you can also create, advanced users can create their own environments. Again, reproducible might help with that, for example. So Jupyter, RStudio, MATLAB, Stata, and so on. So, and of course you write the notebooks and markdown documents and so on. And then we also have access to external data sources. So right now we have, for example, support for a data federation called Data One. Some of you might know. Globus, the Dataverse project, the Reverse, and Zenodo. So, and you know, other external data sources could be registered with the system as well. And then once you have your tail created and executed and all of that, and you want to share it, then you can share it again back to some of these repositories. And today we're going to in particular put something into Zenodo. Okay, did I forget anything here? So here are sort of the steps. You authenticate, you create your tail. Often you customize your tail environment, for example, via reproducible. We'll do some of that. And then you create or upload code and data, and then you share the tails with other users. And you can then optionally register data. So if you say you use public data in sort of a read-only form, and you want to refer to that and give sort of these folks credit, then these links to the external data will be visible and will be part of the tail. All right, and and of course you get a persistent identifier, all of this good stuff. Okay. So a couple of key features of Wholetail. I already mentioned we support popular IDEs, and there's 3 dots, so other ones can be added. There's a simple notion of versioning, pre-publication, post-publication, after the editors told me I need to change everything. So you could have that. You can share. There's a feature that's, I think, unique, where our system is quite different, I think, from other systems, called recorded runs. Recorded runs is you execute your sort of top-level workflow and say, record this, and then the system captures all kinds of provenance information, and that becomes part of the record. So that's really known. You actually ran this tool on, in fact, this particular version of the data set and so on. All right, and then we have some integration with third-party platforms. So we'll see some of that in action. So move forward swiftly. We're also planning to do additional things. So for example, Visual Studio Code environment. We're currently not publishing container images. Those of you in the know will notice that Docker, when you have Docker files to build a sort of an environment, something that works today might be broken tomorrow, or more likely next week or in a month. And so one way to deal with this is to have the actual image itself archived. It's not a perfect solution. These are bulky, images, but it's sort of an option for certain use cases. We also want to be able to combine multiple languages in a single environment, have increased computational resources, memory and cores available. And then also we're looking in a current new initiative to look at accessibility improvements of folks who are, for example, visually impaired. How can they use this environment? So we're trying to pay attention to that as well. Currently, we have about 1,300 registered users and about 2,300 tails. It's being used in research. It's also used in teaching, class settings and so on. The domains based on current collaborations that we have, there's a lot of application in social sciences, also environmental sciences. And of course, I have put here one bullet here. Hopefully this community, some of you will find this interesting, and then maybe we'll have an entry to your community here. And we're also using the system as part of a collaboration with folks on to use it in journal reproducibility audit workflows. Okay, so just very briefly, what is this? So we have a collaboration with Cornell Labor Dynamics Institute and University of North Carolina, the Chapel Hill, the Odom Institute. And so here are, again, this is not your community, but you can imagine kind of what they're doing. And what happens is that if you submit a paper to these journals, the journals have, very particular requirements when it comes to digital artifacts. I mean, you need to upload your data or provide your data, but also your code. And they have particular sort of data editors, verifiers that check sort of independent from the scientific review. So there's the scientific review, which is done sort of the conventional way. And in parallel, there's an artifact review where somebody checks that the code sort of checks out and runs and produces results that are in alignment with what the paper says, okay? So, of course, ultimately it would be nice if we can develop environments such as Wholetail that make this really easy, so we don't have to hire a whole new class of people who do lots of extra work, or at least make their work easy, so then maybe, we can scale this. So anyway, so we're currently evaluating this. We have a collaboration with them, So we have, so Odom Institute has a project called Confirmable Reproducible Research Environment, Core 2 or Core 2 or Core 2, and we're working with those good folks as well. Okay, a couple of quick survey results. We were asking you, those who've signed up, what you're using. What are we seeing here? So a lot of you are using Mac OS and Windows, and then a few of you are using Linux. Now, this doesn't have to bother you, but internally we're using, but we're using a Ubuntu operating system, a Linux operating system. But again, you're using it through the browser, so you sometimes maybe you don't have to worry about that. In terms of languages, we see Python is very popular, and so is MATLAB. So we have in the clinic a little MATLAB demo built in as well. And I'm looking at time. R, not so much in this community. You're doing not as much statistics. I see heads shaking vigorously. You want the big compute stuff. Fortran, there you go. Excellent. That's it. Way to go. All right. Which IDEs do you use primarily in your research? So Jupyter and Jupyter Lab is the number one here, and that's what we're also going to see. MATLAB is number 2, and then I think if I see this correctly, Visual Studio Code comes next. Okay, great. Do you regularly use source control? So many of you use Git or Bitbucket, and then well, 2/3, almost 2/3, but there's also many of you who don't. All right, and here's the tutorial, and let's jump in. Unless there's any immediate questions. While there's a question.
I have 2 questions actually. One, when you publish your Wholetail, can you put some sort of a license with it that tells people what they can do or what they can't do with it?
Yeah. Okay. Yes, we can. And again, this is if some of my remote collaborators want to chime in, you want to say anything about licensing in particular? Craig, I see you're there.
And we don't cover it in the tutorial. There's a section for selecting a license. It's relatively limited, but you can always put your license directly in the workspace as you would a Git repo. It's just a folder. So there's no, within Wholetail, there's no limitations on that structure. Our metadata has some, you know, hard restrictions, but you don't necessarily have to use those.
The voice from the ether, I just wanted to show you here.
Thank you,
This is
Greg.
great. Okay, there's another question.
I was curious about size constraints in terms of like how big code and data sets can be, and also in terms of processors and
Yeah, size
multiple
constraints, the short answer is yes. And the detailed answer I'll pass to Craig as well. I think we have, you know, we have sort of run-of-the-mill standard virtual machines set up. And if you have particular requirements because you have a very compute-intensive code or that has particular requirements, that's something we would have to possibly, you know, set up first or you know, even extend the system. Greg, did you want to say something about resource constraints? Mm-hmm.
And it's a big issue for us. So we have Wholetail was kind of envisioned as more of the laptop in the cloud. So it should have specs compatible with, you know, a fairly, I don't know if standard is the right word, but at least common spec laptop. And we would like to really increase. We are ultimately constrained by the VM profile.
Still there?
Oh, can you hear me?
Because I switched displays.
I am here. Can you hear me?
Yes.
Yeah, we can hear you.
Okay, I thought. So we have some fairly hard limits on there right now, and so large data, very large data, with thinking of for technical folks, just network shares across a cloud cluster. We have CPU and memory limits that are configurable, but the limits are pretty low right now. But this is an area where we're really hoping to expand. And so more use cases. So if that's a constraint for you, you can't really practically use the system because of it, then we'd want to know. More users that encounter this give us more motivation to solve it.
All right, well, thank you for your questions. So you should all be moving now to this wonderful GitHub repo that Craig has set up. And it looks just like any old GitHub repo. There's a link to the slides. Again, the slides have also some references. And let's just jump right in. And I hope you can see this. It's sufficiently large here, right? I think. Okay, might want to scroll up a little. Okay, browser requirements. Apparently, it's working best with Chrome and Firefox. You can also join a Wholetail Slack channel. So if you click on this thing here, I don't know whether it'll take me to the right place, but we'll see that momentarily. It wants to actually open the app, which I don't want to really do right now. And I also forgot to right click. So let me hit the back button first. But I have this channel open and you can ask questions there. Give me a second. So here's a window. So those of you who use Slack or so there's a channel specifically for this tutorial today or for this clinic today. So that link here should bring you somewhere that hopefully will, you know, allow you to ask ad hoc questions. I see somebody's there. Hey Neil, welcome. And all right. So reporting issues. Those who want to make sure your comments are not forgotten, you can also directly, again, we're again on this website here on the GitHub repo site. You can directly submit issues, if you like to. That way, nothing is lost. All right. And again, survey at the end. If somebody runs out, of course, now you have not much to report on, but okay. All right, let's jump in. What is a tail? What is Wholetail? What is a tail? I already said that, so we can skip that. What is a recorded run? I will say something about that. And what are Docker and repo to Docker and why are they used in Wholetail? Yeah. So we want to learn about these things. So I said this, I can skip over this. Wholetail is an open source platform. Okay. What is a tail? I already showed this. Data, code, workflow, documentation, results, and information importantly about the computational environment are all packaged together. You can also see that you can do this whole thing by yourself. I'm just reading for the time being. What is a DOI? I think I'll assume most of you know this. If not, just read it. I'm trying to catch up on time a little bit. All right. What is a research or a data repository? Of course, you're familiar with those as well. Institutional data repositories provide a way to preserve and provide access to research materials and artifacts. And again, in Wholetail, we work a lot with Zenodo, but also Dataverse, Data1, and Globus. Reproducible computational research. I spent minutes on that, so I won't repeat myself. Let's come to activity 1. So activity 1, I invite you to join me. We're not gonna jump into Wholetail right away, but we're gonna just look around, and we're gonna pick a research compendium package by, I'm not sure I can pronounce this correctly, Dalpoim, Guedes, and Bozinski, I know him, from 2018. So there is a published research compendium. So let's just click there and take a peek. Yeah, so you see you're brought to Zenodo. This is the compendium itself. If you've used Zenodo before, this will look very familiar. You can download this compendium from there. It has a DOI. You can, yeah, this is your sort of persistent archive. All right, now let's go back. I should right click here. Otherwise, I always have to do this painfully. So when you right click here, open link in new tab. Let's look also at the associated GitHub repository. Okay, so there's a subtle difference, right? The GitHub repository and the archive is not quite the same thing, although the actual content the digital content on both sides is the same. But one is a published research compendium that's referenceable, can be referenced, and it's persistent. It'll be there for a long time, as long as Zenodo is there. With GitHub, we don't know. And also it has additional features that a general repository might not care about, like a DOI, for example, among other things, and certain kinds of metadata. All right, so if we go to the GitHub repository, we can explore what these Bozinski and co-author, what they have done here. This is just a regular GitHub repo. You see, it also has, in fact, a DOI. It has a license, MIT license. It requires R at least 3.4.3, so R. It also failed, so some build failed. So there's probably some continuous integration or some sort of mechanism at work that tries to rebuild the application. And as we see, these things run for weeks, months, maybe years, and then they don't run anymore. So in Wholetail, we do a little bit something about that, but you see that, yeah, I mean, archiving maybe the image is one way out, even though we're not currently do this explicitly, but this is possibly one way. So the last change you see was 2018. So I'm sure when they made the last change, that didn't say failed at the time. Having said this, this is a very good repository. It explains things really nicely. So I would like to take a little time to just quickly go through this with you together. So it says, when using the code included in this research compendium, please cite all of the following. So there is a Science Advances paper that has a DOI. There is a link to Zenodo here, research compendium. So this is the paper, right? You see climate change stimulated agricultural innovation and exchange across Asia. It's nice, the title says it all. Then the artifact, that's the research compendium. And then there's data output for, so there's even a separate data artifact that also has a DOI. Okay, so if we want to follow what these good researchers tell us, please cite the paper, please cite the artifact, please cite the data. There's a question?
I was curious about the order that you usually do things in. So like if you're getting toward the end of a project, are you usually creating the data artifact before you submit it and then giving access to it for the peer reviewers? Or what if there are changes that you need to make as a result of the peer review process? How do you handle that?
Yeah, so sort of, it's almost like a chicken and egg, right? So almost like a deadlock, what comes first? Well, again, I'm looking here at Craig, who is also leading this collaboration with our journal verification folks. So the way I understand it is that often, say, if you are in that verification business, which is sort of, yeah, maybe the most advanced form, is that you would share a version of your work, in our case, a tale, with the journal editor, who shares it with the artifact reviewers. And then, of course, as part of the review process, there might be some changes happening. This is also where a versioning feature can be can be useful. And at the end, when things are accepted and say, okay, artifact review is okay, then the DOI that you create at that time, you can then put that sort of in your publication. Is that
Yeah, what if you
breaking
are
some of
part
the
of Craig's
dependencies?
trial, do you generally recommend
Uh-huh.
doing it like after you finish the peer review process?
Well, I think sort of the way I look at it, it's a multi-step process where, I mean, it's the problem particularly with the DOIs, for example, because there's these three artifacts, right? There's the paper that's published, there is the compendium, and there's the data, all each having a DOI. So you're asking how, in which order they might have been created, or?
Or I guess my question is, so like if you put it online and you get a DOI and then
Yeah.
you have to make a change,
Yeah.
you need to do a new DOI?
Oh, yeah.
Uh,
So for example, Zenodo supports, I think, versioning, just like when you publish a paper, say on archive.org. So you would have, on the one hand, you would have it both ways. You have a unique identifier, and then that identifier may or may not have a version number. But if you just use the identifier itself, you will become aware of the fact that there are multiple versions, and then you can pick the latest version. And if you want to reference a particular version, because you say this run, for example, I ran this results with a preliminary version of version 2, and now there's version 7, that would be transparent. So yeah, life is messy in this way. Craig, did you want to add anything on this?
Yeah, I'd also just say that there's different conventions and communities. So in this example, this is a researcher who's kind of self-motivated, very open in their work. So they're using Zenodo, they're probably taking advantage of the conceptual DOIs. There's version DOIs within Zenodo. They don't mind publishing their stuff publicly and making that available with a digital object identifier during the publication process. Whereas with some of our social science collaborators, it's all very private. So you're in the peer review process. Dataverse and OpenICPSR, the repositories they use, they have private draft notions of data sets. And so you're sharing with the peer reviewer a private record that's not in GitHub. And they'd probably, in the metadata record, they'll use some sort of forthcoming notation, like a parentheses forthcoming in place of a DOI or in place of the citation until it's ready and they can version those records there. So I don't think there's a easy recommended practice there. The idea of the conceptual DOI in Zenodo is very nice because you can have one overarching identifier that references several versions, and you can reference the individual version specifically too. That's not present in every repository. So, and not everybody uses something like the Git integration to do that. So sometimes you're just uploading data into the repository directly. So murky answer to a difficult question, I think.
Thank you. Thanks, Craig. And again, I should say again that Karl Buzinski and collaborator here, that they, I think do really something very, very transparent, very open. They have not used the wholesale system. So part of showing this is also to show sort of what you can do on your own and maybe also how painful it is. And some of these pains we want to alleviate. Yeah. Okay. And protecting your data, so having it transparent, but also protecting it while you're still working on it is a tricky business, but there are ways to deal with it. It's sort of the brief summary, I think, here. Okay. All right. The files at the URL above will generate the results as found in the publication. The files hosted here are the development versions and may have changed since the compendium was released. Again, that is also a recognition of the fact that things keep moving. So you've published it, here's the snapshot, but now the software has evolved and you can go back to the old version, you can use the new version. Here are the authors, just very briefly, overview of the contents. So they also use Docker. The compendium is an R package. You will install most required dependencies. They follow what is in the R community very popular, Ben Marwick's RR tools package. All right, Markdown vignette downloading the compendium. We're not going to do this now, but you could, of course, now download this either directly from GitHub or you can clone it via Git. They talk about the system requirements, how to install it natively, if you like, in macOS or on Linux or on Windows. And basically on Windows saying, don't do it, then you use the Docker build instead. Issues with the R vector memory exhausted. I mean, I really have to applaud these guys for putting all that effort there, right? They really want to do the right thing and make it easy for others to reproduce their stuff. Okay, I think, oh yeah, interesting here. I noticed they're running approximately 12 hours. So you won't easily just do this between lunch and coffee break, maybe. So yeah, we're not going to do this, but you see, this is really very good practice here by these two folks. Okay, so we've explored that. All right. Briefly, what is Docker? Docker is a popular virtualization or container platform, has been widely used or widely adopted for packaging, distribution, and deployment of software, including scientific software. In particular, those of you who have felt the pain of installing anything really complicated on your own laptop, computers, we all know it breaks stuff all the time. Not all the time, but often, too often. And Docker is in some sense a way how you can have your cake and eat it. So you can install Docker and then install the applications that you want to use inside of Docker containers. So you kind of keep these things a little separate. That's sort of my very high level explanation here. A Docker file is a simple text file that contains instructions used to build a Docker image. So let's talk about the images, right? You're creating in some sense a virtual computer inside of your computer where you can then install or have all of these different environments that might otherwise be in conflict with your local installations. Yeah. All right. I mean, this is not a Docker tutorial, but you have here pointers that help you in case this is new technology to you. When we look at a Docker file briefly, what does it say? It says, for example, here Ubuntu 2004. So this is sort of, I think, to the extent I understand this is where you start from. This is sort of your base virtual machine, if you like. And then you say, okay, what things do I need to run my applications? So you say, well, I might, for example, want Python and at least this version 3.8.2. Yeah. And here are installations apt-get. This is sort of a package manager for Linux. And these are instructions that tell you how to put your image together. Again, we don't have to worry about this. There's the different communities have different conventions. Python folks do this, R folks do that. And there's generic things yeah. And we try to support them all in Wholetail. All right. So here's the, again, more detailed explanation. So the base image here is, again, this Ubuntu that I mentioned. LTS stands for long-term support version of Ubuntu. The run instruction uses the apt package manager to install a specific version of Python. An image built from these instructions can be run on a variety of operating systems. So the idea is you put together a computer, virtual computer with operating system and all these dependent software packages, and then you can run it on Windows, on Mac OS, on Linux, yeah, or on whatever comes around next. MS-DOS. No, I'm just kidding. Okay. So what is Repo2Docker? Repo2Docker is part of the Binder platform developed by the Jupyter community. As suggested by the name, Repo2Docker provides a way to convert a repository, in particular, or for example, a GitHub repository, into a Docker image. So basically, you follow certain conventions when you create your repository, and then by following these conventions, you get sort of a Docker image for free, pretty much. Yeah? So you start with a repository, you get a Docker image. That's really nice if you follow these well-defined and commonly used configuration files. Yeah, we can take a quick look. I looked at this before. Let's see what's there. Okay, so there are these environment.yml, so YAML files for installing a Conda environment. Then there's pip file, requirements.txt. You see there's a lot of different conventions, yeah, install.r, up.txt, you name it. So every community comes up with their own little convention and say, hey, this works great. Why don't you use that? And so now you have a dozen or more. I don't know how many. But again, if you follow this set of prescribed ones, then you're in business. Now I've lost your track. So you can look at the list of supported configuration files. Now, in the interest of time, I want to come soon to the creation of a tail before the break, at least that we get started. So I might skip over a few of these things. Okay, exploring reproducible Docker. I think I said the important things here. Do you recognize or use any of these configuration files, the ones you just saw? Anybody is using some of these formats? Nodding, yeah, more nodding. Okay. All right. Okay, it does not currently support it. The app.txt file can be used to specify OS level packages. All right. Let's explore a replication package, okay? So replication data for parliamentary constraints and long-term development, evidence from the Duchy of Württemberg. Now I can pronounce that quite well. I just realized that I haven't looked at that. So let's look at it together. This makes it so much more exciting. Clicking on that. Okay, so this is one of these journals, Dataverse. We're at the Dataverse site here. I'm seeing whether I can make this larger. Okay, replication data for parliamentary constraints and long-term development, evidence from the Duchy of Württemberg. Okay, I guess that's. So what are we doing here? Okay, I clicked the wrong button again. I should have right-clicked this. Okay.
Bertram, would you like me just to jump in on this one, just to?
Please.
Yeah. So sorry, I know it's wordy.
Frank, go ahead.
This is intended as an example to show a community that has a similar requirements that doesn't use Git. So this is AJPS. They require you to distribute your code and data. It goes through third-party verification. If you scroll to the bottom of this, you'll see the files. This is a Stata example. So this is something that doesn't work. If you keep going down, it doesn't work in conventional the binder infrastructure because it requires licensed software like MATLAB. It does nothing to describe the environment except for what's in the README. So that README will contain some very deep details sometimes about the OS and software versions. So if you go back,
data, I guess, terms, versions. Okay.
Yeah, you don't need to go any deeper into it, I don't think. Go back in your browser.
Okay, sorry.
So these were just two different examples of communities and how they package for reproducibility, kind of with different constraints and practices.
So the computational archaeologists and the
social
I guess,
yeah. So
I guess I backtracked too far here.
And I think that's and also that it's commercial software, which I think is still important for the CSDMS community as well, with some MATLAB usage. So some of the conventional open platforms today, and I mean, we extend repo to Docker, but you can't just go create a MATLAB binder right now, I don't believe. So
we have explored these packages now. All right. So again, uses data commercial software package. Wholetail extends reproducible Docker to add support for commercial packages, including Stata and MATLAB. Right. So you are using us, so to say, that we have that license and can use that. All right. Exploring a tail. So here's an example tail based on the above replication package. Before we go there, consider the following. It contains the same code, data, and instructions as activity 4. It has a recorded run with associated outputs, unlike the other thing probably, and it can be imported and re-executed in Wholetail. So let me just quickly mention what is a recorded run. So how do you know that the provided code, data, workflow, and environment were used to obtain a particular result? It's one thing to say, well, I used this, trust me. And the other thing is, well, I have a recorder running, so to say, in the background that when this output is created, keeps track of what was actually used. You might make honest mistakes. You say, I thought I used this file, but some funny path thing, and I used something else, and you wouldn't even know. So this can keep you honest also. You're not only transparent to other people, but you're also transparent to yourself. You can also keep track of, for example, resource use. Okay, so let's take a quick look here. If I right-click on this and open it in a new tab, let's see what happens. Oh, not found. Okay. I was hoping that.
Give it because you're going to create one. I think I put the DOI in the link, and it won't resolve because it's a sandbox DOI.
Oh, I see. Okay.
Oh,
That's
correct.
good. Shows you that this is not a simulation. You're not in a dream. It works great so far, but still, it's still live. Okay. Okay, let's continue. I think at the hour mark, we can take a short break and stretch, get cookies and coffee. All right. So how do we access Wholetail? Let's get into that. So what am I authorizing Wholetail to do? And so we're gonna try and understand this. So those following along on your laptops, you can go and read the exciting terms of use. Everybody loves those. Wholetail enables researchers to log in using credentials from hundreds of research institutions, your home university, say, and organizations worldwide, as well as ORCID and Google accounts. So if you departed from your university and they no longer give you access, you can use your ORCID or Google account as well. Globus Auth is the system that we're using. So Globus itself is a research data management service used by researchers at hundreds of research institutions. It's based at the University of Chicago. It's been out there forever. It's a popular tool for transferring data in high performance computing environments. Anybody here has used Globus before? Yes. Who has heard about Globus before? Those who've used it, you've heard it, and some more. Okay, great. So the first activity, and so we can get started with this. Let's go to the dashboard Wholetail.org and select Access Wholetail. Now I will do something very brave. I will use an incognito window so it looks the same way to you as it looks to me, or rather the other way around. It'll look the same way to me as it looks to you. So when you go to the dashboard, so I'm going to copy that link. Copy link. It's as if I've never been there. So now I have two windows. Now I've got to manage this. Over here is my clinic material, and here is the dashboard itself. All right. Okay, so this thing in the middle is meant to look like a button that you can click on. Okay, hopefully that makes sense. We click Access Wholetail. Aha. All right, so that Wholetail knows who you are, so that when you publish and share your research, it's not Joe Doe doing it for Jane Doe. It's like, okay, you've got to authenticate. All right. So what are we going to use? So I'm going to type in Illinois, because it's my home institution. See whether I can type that. Okay. University of Illinois at Urbana-Champaign. Let's use this one. Continue. Okay, so now I don't like this, but hopefully the browser still remembers my password, because I might not. Maybe this is the time when you realize you don't remember either. Yeah? Raise your hands when you get stuck because you can't log into your own system and your browser hasn't remembered it. All right, so here it is. Let's see. All right, of course, we want to be extra secure. So I need to do two-factor authentication here. Let's see. Verify your identity. Okay. Miraculously. Okay. All right. Now the system, now Wholetail knows that I am who I claim I am.
So just a note, Bertram, that some folks, this was kind of the point of going through the Globus stuff, is you might get a consent message from Globus asking you to authorize access. If you have any questions about that, that's in the documentation, but you're consenting to allow Globus to access information about you, or Wholetail to access information about you via Globus.
All right, so that part, yeah, I didn't show because I had probably previously consented to Globus having this information. Now I just also see here on my cheat sheet, those of you who want to join the Slack channel and ask questions there directly to Greg and so on, circumventing me here. If you go to the project site wholetail.org, at the bottom, there's also a way to join Slack. Yeah, you can use that too. Yeah. So there's a link at the bottom of wholetail.org. That way, if you're not so familiar with Slack or how to get there. All right, so here we are in the dashboard. And so we've successfully did the first step here. You see my tails, and are tails that are shared with me. So these are again, computational packages. And then there are public tails. Yeah, so public tails coming up any moment, I guess. Yeah, when you have created a tail, you can decide, keep it private, share it with particular individuals, or share it with the world. Okay, fair enough. All right, let's see. Okay, so we did this, you know, your institution, this was the login. So some of you, is anybody logged in fact, through Hotel? Oh, hands go up, fantastic. All right. So what are you authorizing? So know who you are, so your name is known, some details about you, say your profile on Globus, transfer files via Globus. We can initiate transfers on your behalf to Hotel. Deriva is another such system. Know your email address. Anyways, your bank account and these other things are safe with you and not with us. So I hope that alleviates some of the concerns. All right, so there's more about the consent. Hotel uses Globus Auth to allow researchers to log in using their institutional credentials. We've seen that. You're authorizing Hotel to access information about you stored in Globus, but Hotel will never see your password. Globus Auth allows Hotel to transfer data from Globus endpoints to Hotel on your behalf. You can always rescind your consent. Okay, it's important. These things are not always trivial, so it's good you have it here black on white. Creating and running tails. Let's do this one thing. Let's create a tail and then take a short break. All right, so you can follow along. Some of you might even run ahead. Okay, creating and running tails. So what we're going to do is learn how to create a tail and learn about the tail folder structure or directory structure and how to rebuild the image maybe after we've installed additional dependencies into the image. All right, creating a tail. Select the Create New Tail button. It's up here on the upper right. Okay, Create New Tail. So if you go back to the dashboard, dashboard.hotel.org, Create New Tail on the upper right, this plus there, yeah? Notice, by the way, you have two choices. You can create a new tail sort of de novo from scratch, which is what we're doing first, and then later we're going to create a tail from a Git repository. Remember, if you have a repository, then we can sort of suck in that information and have a head start, so to say, on that tail. All right, so what we call this, let's be very creative. Let's call it CSDMS example, maybe 3, because I've done this twice before. Still can count to 3, that's good. Compute environment. So you see there are these, quite a few existing compute environments available. And of course, if you run your own Hotel instance, or I don't know, maybe Craig, whether you can say how easy it would be to expand that list. Yeah, I don't know. Craig, is there something you want to say about that? That's normally not what you would do as a user. The idea is we have the common environments there, and you can still install specialized dependencies. So we try to cover sort of 90% or whatever.
Yeah, so brand new environments typically involve a new record in Hotel that we have to do, but it would just be a Git issue. I mean, or a Git pull request if anybody wanted to. It's not you can't just post your own environment. That's an old feature. I don't think that's exposed right now.
If you wanted to use some exotic software like OpenRefine, right? Craig and Casper in particular wants to hear that. That could be say, hey, request, I want to use OpenRefine, and then we'll work on that.
So could this be where we have to work together if we want to have the CSDMS software stack?
Yes,
in a environment, then
that would. Yes, and I mean, we actually reported, I was doing one clinic, actually not I, but one of my esteemed colleagues was creating a tail from one of the other notebooks with the right dependencies, and it worked quite seamlessly. But if there was, again, specialized environments, go ahead.
Yeah, just to clarify the question, you wouldn't need to create a CSDMS specific environment. These are more base environments that would have special handling for installing MATLAB package, Stata package, Python package. These are build packs and repo to Docker, but we'll show you within Hotel today, you can, specify the CSDMS dependencies. It would be a template and make that available to folks. And you don't need a custom environment. They would just need to effectively copy that configuration and they would have it.
Like an environment YAML or something like that, right?
Yeah, right. Or exactly. That's what we do with the LandLabs.
So if you say, okay, we typically use this, then you share your YAML file and then it becomes available right away. Okay, Great. So let's see. Let's use a Jupyter Lab type of tail. So based on Jupyter Lab, create new tail. You can also use just vanilla Jupyter if you like. Okay. So here we are. So this is now. You see, it's me. I should probably zoom in a little bit here. So this is the name of the tail that I gave it. That's the author of the tail, or the creator, should I say? Okay, and let's see what we want to do next. So we can, of course, edit the metadata, title, authors, description, license. Yeah, we can edit it right here. Specify an image that displays in the wholesale catalog, change the interactive environment. So we could change things if I click edit here. Yeah, if I click edit here, you see also, and we'll look at that in a moment, maybe after the break, how you plug in your ORCID ID. Who knows their ORCID ID, or at least knows where to find it? I don't know mine. I know where to find it. I did find it. I have a very strange ID because I think I did this early and never again. Oh, it's all the zeros here. Okay, we'll come to that. Okay. Yeah, question?
So from the license list, there are 2 options.
Licenses? Two options only.
What if where you want to add some other license, is there to edit?
Yeah.
Yeah. The licenses that are listed here are content licenses. So you can, so one, if you have a strong, like this came from kind of advice and something we haven't revisited, a strong preference for a content license. That's not one of these, it's something we can add. But I would just suggest if you're looking for something more like a software license and not the content license, that you would include a license file as you would in a Git repo just in your workspace for now.
Again, content license versus the software license itself, that might be sort of buried, or not quite buried, but exposed further down as part of the archive, along with the actual files. Let's say you have a MATLAB or Python or whatever file, Stata file as part of your bundle, as part of your tail. That's where you also put the license for that maybe particular software that is required to run your software. Okay, all right, so let's see, what are we doing here? I should plug in my ORCID ID, and sure enough, I don't know it. Let's see whether we can find it. ORCID, it's still in my browser history. How about that? Okay. So I am sort of confused. The fact that I'm in an incognito Chrome window doesn't mean it doesn't know some things. Well, I think I was in incognito before, not sure. Anyways, that's my funny ID. And I'm going to copy that crudely here.
I think you may want to take the full URL, Bertram.
Take the full URL. Okay. Okay. Thank you for the heads up. Would be nice if there was a copy button right next to it, but no, that's asking too much. All right. So we plug that in here. Yeah. Okay. Okay. What else do I want to say? Live demos are fun. All right. You can also plug in an icon and illustration here that, in a sort of an overview and a tile kind of display quickly tells you which tail you're looking at. I'll just go with a generic one here. And I say save. Okay. And this is all good. And now we can look at the directory structure of a tail. So we can look at the files. So we are basically in this dashboard view of the tail. So just briefly, and then, so we're in this dashboard view of the tail. You see there's an interact item. You can interact with the tail, but for that you need to run it. It's kind of like you need to boot your computer. Yeah? Switch on your computer, otherwise you can't talk to it. We haven't done that yet. But we start with the files to get an idea of what is the folder structure that comes with the tail. Okay, so let's look here at our cheat sheet. So each tail includes different folders that are accessible, one through the whole tail dashboard, and two mounted into your running environment. So when you now run the tail, you can also use these folders. So let's have a look. There's something called the tail workspace. This is the primary folder that contains code, data, and documentation required for computational reproducibility. Then there's external data. If you use a data set that can be accessed through a URL or GUI or something similar, you can register that. And then your tail doesn't need to suck that all in and make it all part of your compute environment right away. So, but that's sort of on demand, okay? There's a versions folder. So you can create different versions of the tail as maybe you make corrections, maybe as part of interactions with the editors of your journal. Yeah, and so you can create different versions. Now, runs is a particular thing that Wholetail has because, again, you can have this recorded run. So you run your script workflow, yeah? And if you have multiple runs, those get sort of also traced, if you like, and put in the runs folder. And then there's also a home folder, which is not really part of the tail. That's where you as a user have your private space for, various things. So it's a private folder that when you log into Wholetail again, into a different tail, creating a different tail, you'll have the same environment. So it's not part of a tail. That's more like, when you log into a, computer which has a shared file system. That's your home directory, if you like. Yeah, all right. Okay, so there's more subtleties, but I don't want to go into all of them because Craig did such a wonderful job of writing it all down for you. Okay, so we run this and then we'll end for now. So run the tail. So now we're basically building from the instructions. Yeah, what's happening behind the scenes? We're building this virtual environment now, this container, this image, and we're starting it. So somewhere on this chat stream, cloud resource, NSF funded, the tail is now running. And it's just booting. I mean, first we have to make that compute environment. We have to build it first with the Docker instructions or based on whatever environment definitions we had, specifications. And it'll take a moment. And I think here it says actually already success. Here it says please wait. So we're dealing with that cognitive dissonance a little bit. But the success will soon enough show the actual popular Jupyter Lab environment coming up. Okay. So there's a question in the back.
Did you just click run tail? I'm sorry, I missed.
Run tail. Oh yeah, sure.
All you did was
I did
click
run tail.
Okay.
Exactly. And it'll take a moment. This up here. So let me also show this. So you can look at the log. The log, what does the log say? Okay, it says things like cached image exists for this tail. So because I was running this tail before the build, there was sort of a shortcut to the build, right? So we didn't have to build it sort of from scratch. So sometimes when you build this environment for the first time, it can take a while. So you shouldn't be discouraged. It just takes a while. But once it's been built for a certain amount of time, it'll be available and it's cached and it's building faster. It tells us something about mounting, launching container for a tail. All right, good. So we acknowledge, say here we click acknowledge all, and we have this environment. Now, screen real estate is getting a little tight here. So what we can do is we can click on this button, this pop-out button in the upper right, and we get a little bit more of what looks like a normal Jupyter Lab environment. Okay, so this opens in the browser a new tab, and that tab has basically a Jupyter Lab environment the way we love it and know it. Here it comes. These are the moons that have to circle orbit Jupiter first. Okay, and then we should, let's see what we're doing next here. We want to download some example files, and then, so there's a CSDMS example file, we'll be downloading it. Do you want to keep going or do you want to break? I promised to break longer. We'll keep going, huh? Okay, who wants a quick break now? 5 minutes. Okay, who definitely does not want to break? See, it depends on how you ask. Let's take a short break. I know you're eager, but let's take just a 5-minute break until 45. Yeah, does that sound good?
If somebody needs a restroom, they're right outside that door, kind of follow
So
that
it's 2:40,
hallway.
let's take a 5-minute break. But we can continue here. It's an informal break, right? So people want to stretch or get up. But if you want to catch up to this point, now is a good time too. I can walk around catch up with you guys, okay? So I'm going to put this here, this activity, this is where we are. We're going to download, first thing when we come back, download this data file or this package. Anybody? Yeah, okay.
Yesterday.
No.
Oh,
And,
yeah.
neither.
If you're not
Me
connected,
neither. We
so
can just
I'm
ask
trying to
questions
connect
here.
to the other one.
Because
Because I was on Eduroam and it didn't load, or I got errors.
yeah, yeah. Can you test whether you're live, like by just opening a new tab? Yeah.
Maybe it's.
I had the same issue. I have two laptops here. One I automatically connected to Eduroam. The other didn't. Nobody asked for this.
So we can confirm.
Yeah, so what's your live? Yeah, what's your?
There.
Exactly. Here, these
Maybe
ones you
just
can probably.
acknowledge.
Acknowledge one. Oh,
Click
that's
error.
okay. Well, how about you do a reload, maybe just refresh the page.
Refresh.
to see what-
We got a lot.
Yeah.
I've not seen that. Yeah. See which is running.
Yeah.
Okay, yeah.
Yeah, that's fine.
Stop, maybe stop. Just- Okay, yeah.
Yeah, there's some boards where I was like.
And because it was.
And then we got back.
We can put the other way. Creative fall,
Yeah, I'm getting there.
What does it say at the bottom? Sir? Okay, this is another thing. Oh, yeah,
Maybe
yeah.
maybe that's what's happening. Oh, now my Wi-Fi's off. I didn't turn it off. Okay, let's see. Maybe it's just my network
If it
connection.
loses the connection while it's trying to talk to the system.
Yeah,
Hmm.
I know yesterday when I was able to connect to the USB system, everything was working. So I'll keep trying to.
Yeah, the other thing is, you could try to go back to the guest if you want. This is-
Oh, no, it's not. No, it's not. Okay. Yeah, absolutely.
That is the one thing that you're not connected. Oh, sorry, you're not connected.
Okay.
Are you okay?
This is the other one, yeah.
Try to get. Yeah, I'll try. I'll try. Yeah.
Yeah.
No, I love it. Because, I had like 4 different schools IDs, and so it just like integrates with them and then get your citation.
Yeah, I was a little concerned.
If you change. I shouldn't be because I slept a lot compared to. So definitely with.
Once you create a purpose,
And like mentally,
And
I
then-
checked out. Because I've been on.
somebody found a bug or something. and you could use. Does that mean you get a second version? Because you already created the UI.
It's a little bit like the paper.
Okay.
So, but you can, that will work.
Would you go?
So I think this only I do have some conceptual.
Oh, okay.
Actually, I thought it is.
Okay, so your flight didn't get canceled.
There is a particular URL.
That's good.
follow
'Cause I know-
version.
Yeah, I know a lot of people's flights did.
Yeah, I guess it needs to be.
I don't know. I mean, it sounds like people's flights tonight are getting canceled.
Yeah.
Yeah.
This would be the same.
Yeah.
Enforcement.
I know people have flights at like 7:30.
Well, that's what it is.
You might wanna, yeah, maybe, yeah, because I know it's about the wind. So hopefully you're fine, but maybe like check your email and see if you've heard from the. Oh, yeah. What's there?
Maybe schedule our flight.
Really?
Or
Well, it's like it's not a corporate like I have colleagues of mine there.
Oh,
So we're
Millennium.
we're with the so it's like
Oh, okay. What? That should be fun.
You can't stay in the highest.
Yeah, I mean, it's like this. Yeah,
no, but
exactly.
it's super nice. You know, it's not like any or video.
Right.
There are huge stories.
Yeah.
I think
Yeah, no, this has been a lot of fun. I'm really glad of this. So is this your first year here? Or?
Yeah.
Okay. Are you gonna be back next year?
Tuesday.
Okay, great.
Yeah, this is your first time.
Yeah, this is my first year. The spring school, yeah, I'm definitely gonna apply that next year. Are you? Yeah, I guess so. I mean, it's all like no, like, I think it'd be helpful. I really like being here. You know, I should be fun to do. Oh, yeah.
Because right now you are master.
I'm starting my master's next year. So currently I'm in math. So math right now, but then next year I'm starting in subspecial education. So not exactly more for like surface processes, but I'm still involved. Yeah. Yeah, and then so remind me of your.
All right. The house shall come to order, please. Greg, are you still there?
I am here.
You're here. Great. Okay. 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 So we might not all get through everything. We have about 45 minutes, 40-ish minutes, but we will see. Still see more things. So, all right. So let's continue where we left off. So hopefully you have a tail created and running. If not, again, look over each other's shoulder, keeping, I don't know how many feet distance now. Just not we're done with that. But anyways, download and extract this file. So let's download here. Let's right click here maybe, or just click on this. What happens? Okay. Get a little beach ball. Okay. So there's my flight for tomorrow. You don't want to know that. Clinical tail, all right. So you see, I've already downloaded this before, I think, so I'm gonna download it again. In fact, I'm gonna replace it so it gets a new timestamp. So this is a zip file. And so I'm using a Mac here. Of course, it might look a little different on your system. The zip file contains a little land lab example, sort of a simple tutorial from this community. Then environment.yaml, which is the conduct configuration file to install LandLab. So this is saying, in order to run this application, we need not just Python, but also maybe these two other things. And then there's a top-level convention often, there's a top-level file that by convention can be called run.sh, which sort of is a shell script that says how to run the application or your study, whatever it is. So let's click on that zip file here. On this wonderful Mac, it's automatically unzipped. And since this is very small, I'm going to open it over here. Hopefully, in what folder are we? Sorry, clinical tail. All right, so. If only I remember where I put this. Okay, all right. So Mac will help me to say where this is. Okay, hold on. It is in clinical tail, which is in Colorado, my travel folder. Okay, just where it should be. Give me a second. Now you're getting way too much information here, but makes it also interesting. Travel. And then I go to Colorado. And then I have a clinical tail. So this is my sort of editor that I like using, Emacs. It's not strictly required when using Wholetail. Kidding, it's not at all required. And this is just my way of finding my way around on the local file system. So you see here, I downloaded locally, in fact, now for the second time, this CSDMS folder. And we can inspect what's in there. So I'm going to use the second copy. Why not? And you see there are 3 files in there. Again, you might just right click and open it in your favorite browser of your confidence. So there is environment.yaml. This is a YAML file. This is basically a structured file that says, we're going to call this application here, the land lab tail. And then there is stuff that describes the dependencies. Yeah. So land lab greater or equal 2.1, and then depends on PIP. And it also depends on DASC and HoloViews and MESA and BMI topography, at least 0.5. So these things probably mean much more to you than they do to me. So that's part of the zip file. Then there is a Python program. So that's something that I can read a little bit better. Since also Zoom is running, this CPU with I don't know how many cores feels very tired already. So that's why you get some delays here. So this is the Python file that's part of the zip file that we're looking at. Right? It itself, imports NumPy and operating system stuff and certain functions from the land lab module and so on. All right, so it's a simple script. And in the end, it creates two figures. You see here, say figure in a figure subfolder, figure 1 and figure 2 PNG. I think we'll see those figures in a moment again. And then run.sh is really sort of a shell script that is our entry point into this recorded run. So if you want to run this particular application to create our artifacts for our, say, research paper, and we want to switch on the recorded run, we need to tell the system, well, how do I run the paper, so to speak? And this is what we're saying here. We're removing recursively and forcefully the figures subfolder where the published results, so to say, appear. So we remove whatever was there, and then we run the script using Python, whatever version is specified elsewhere, and then we'll get some output. Okay, good. So I think this makes all sense. Now, we could run all of this locally, but we want to do this in a controlled environment, right? That we want to share. So these files, these zip files, we have to put it into our tail. We have to make it part of the tail. So how do we do that? So let's read the instructions first. Select the Files tab. Okay, we can remember that. Select Tail Workspace and hit the plus button. Okay. So where are we? So remember, I tore off the Jupyter Lab into a separate tab. So I go back to my dashboard view of the tail. Okay, so remember conceptually. So this is either what you had earlier in your dashboard view, or if you sort of had the pop out. Yeah, that's why I had to go back. Remember, here we are in the dashboard. We're running the tail that I just created a moment ago. And here's the Jupyter Lab environment sort of running inside of Wholetail. That's our computer running inside of Wholetail. All right. So, but back to the tail view, we want to upload some files so that they become part of the tail. So I click on Files, and then I should load them into the workspace, not in the home directory, wrong place, workspace, right? As the name suggests. Plus, upload file. So now we're loading the file from our local computer into the tail. Let's hopefully go to the right place. It's not the quick start folder. It's the clinic Wholetail, and it's the CSDMS zip file. And in particular, in that zip file, once you unzip it, are three files, the three files I showed you. Run.sh, the environment to build the application, and the application itself, in this case, a simple script. You can upload them one at a time or select multiple and load them together. All righty. And now they have been uploaded from the local computer into the tail, yeah, into that running instance. All right, so that seemed to have worked just fine. Now we want to customize the environment. Okay. All right, Wholetail allows you to specify software dependencies. Using reproducible. We heard about that. The uploaded Conda environment specifies the dependencies that this land lab script has. Yeah, but they are not yet installed in your environment. So notice we were starting a generic Jupyter Lab, just totally generic. And the dependencies that we got from that zip file said, hey, I need this and I need that. We haven't installed them yet, so we need to install them. Okay. So for that, what we do is we go again to the tail view, and these very obvious three little dots. It's always in life, behind those three little dots are important things. We click on that, and we say rebuild tail, because we've uploaded dependencies, right? So we told sort of that remote computer, hey, in order to build this CSDMS demo, you need to install these dependencies. and by explicitly telling whole tail to rebuild the tail, it says, look what files you have, follow one of these dozen conventions to build environments, right? In this case, it was a environment.yaml file. All right, so we rebuilt the tail. So now we should see building image, right? Sort of a new computer is built that now has, new virtual computers built that now has these additional dependencies installed. When it says success, as it says here, yeah, looking at the logs, cached image exists. In this case, against, I did this before. Okay, that's why it was fast. Acknowledge all. All right, so now we want to restart the tail though, right? So the computer that's still running, we want to restart that now to take advantage of these new things that we just installed. So let's say restart tail. So it says updating instance, that makes sense. It's restarting the tail. We see a little progress bar. Okay, and then let's see what happens next. And now we run the example program. With the LandLab dependencies installed, you can interactively run the script. Open your Jupyter Lab interactive environment. Yeah. And then from the Jupyter Lab, we say we run the, actually we'll do it very old fashioned. We create open a terminal and run it from there. It's one way to do it, okay? So if my mouse battery, so I'm going to copy this, yeah, in case you follow along. So this one was also successful. I say acknowledge all. Now I click on interact. We want to talk to our environment, or I can probably use the existing tab that I used before. I think this is connected. Craig, can you confirm that my?
Yeah, if you do it quickly after the restart, sometimes you'll see it should be fine now. So go ahead and try, and if not, we'll.
So this tab, this independent tab, is in fact talking to the same instance. So it's not sort of disconnected and doing its own thing, hopefully, most of the time. All right, so now we wanted to say file, new, I know this is a little small to read here, so I'm speaking it out. New terminal, we go old fashioned, creating a terminal, right? From the 80s, and say Python LandLab. Yeah, terminals are good, by the way. 80s were good times. And that's all right. So here we go. So we're running again inside the container. We run that LandLab example.python. We see it produces some interesting output from 0 to 95. I think it's learning how to count in steps of 5. Maybe it's doing something else too. Also, there's something that looks like warning, maybe standard error output. We don't get concerned about that because that's part of the demonstration that is intended, let's say. What does it say? We can take a quick peek. Matplotlib deprecation warning. You are modifying the state of a globally registered color map. In future versions, you will not be able to modify a registered color map in place. To remove this warning, you can make a copy of the color map first. This just shows how life keeps evolving. And all right, let's follow the instructions. Confirm that the figures folder is created and that it contains 2 images. Inspect the images. Let's do it. Okay, so there's a figures folder, right? I used the Jupyter Lab environment, so it has a little file browser here. So I open that. Last modified a minute ago, figure 1. Oh, yes. Some of you will know this figure. Actually, I don't know what it's meaning. Who can explain that figure to me? What's the science behind this?
I think those are river profiles.
River profiles. Yeah. Good enough for me. Okay. Figure 2. The quiz continues. That looks like a fractal, but it's also something with rivers.
So this is a mountain, and rivers will flow. So mountain is in the middle, and the rivers will flow to the lowest point.
Fantastic. And these files have just been created by that script. We'll see in a moment that we can record this and all of that, but let's not get ahead of ourselves here. So here it says, okay, we confirm that it was created, contains the images, inspect the images, remove the figures folder. Now I tried this before, it's not so easy as you think. If I click on figures here and say right click and say delete, are you sure you want to permanently, I mean the instructions say, so we say yes, delete. I said, well, it's not empty. All right, so you've got to go in there, select the files, delete the files. It's kind of a safety issue, right? That you don't accidentally delete something. And then you go back again here, and then now you can delete the figures folder. Why are we deleting the fruits of our labor? Because we want to do the recorded run. And then recreate it one more time, all right? So I'll come to that. So this output was created, you've seen it, the numbers from 5 to 95. And there was also some warning, deprecation, blah, blah, blah. And now we're going to start a recorded run. So this is a special feature that only we can do, I think. So we go back to our dashboard view. And over here, you see this wonderful tail history icon, yeah, that looks like a clock going backwards in time. Time machine, be careful with that button. Select the perform run button. So we go here. And you see here a button opening. Sorry, this is a little bit in the way now. We put you somewhere else, Craig and Casper. So perform run. Enter the path to the entry point for your code. So again, we need a top level script that automatically runs whatever you want to run. Of course, you can customize your script, give the script a different name, but have a script that runs 10 other scripts that creates 100 figures, whatever it is. Okay, in this case, it's just run.sh, which reruns that land lab thing. Okay, perform recorded run. All right. So, recorded run, we see here, basically that the system is telling us that something's happening on that front. Building image, recording run, look at that. And success. All right, click that away. We've noticed that this is successful. There's also tail history. You see there's a recorded run now from 3:02 p.m. That looks about right. Okay, now we're going to inspect something. So what's been happening? A version of your tail is created. So basically, before we run, we say, okay, so let's snapshot, so to say, the current version. So we have that controlled. And we can also go inside the container again into our terminal. I'll do that in a moment, and look at the versions that exist there. So let's go back to our running Jupyter lab, and let's go into the terminal. We're still here in the terminal, and the instructions were to do an ls from the parent directory and the versions subdirectory. And then you see there is a new version, Thursday, May 19th at 21 hours. That's of course somewhere on this planet. It is now 21 hours, maybe in London, I don't know. Not here. And that's I mean, we can explore this here, right? We can also literally go up one level, look at what's in there. Wait a minute, where's did I take the wrong turn? Okay, I need to go one level up. All right, so you see here, can I make this bigger? Data, home, runs, and versions, and workspace, yeah? So our tail has these folders that we talked about earlier, and we just looked at, did you look at versions? Yeah, there's only one version in there. And how about, let's look at runs, what's in there? There's a run in there as well, okay. All right. So you can have a version of a tail, but you may or may not have run it. So the run is really sort of, that has some trace information. The run contains a reference to the created version plus results, outputs, and container statistics. The run should complete with the status success. We did that, or completed, it says, I think. The easiest way to inspect the run is in the Jupyter Lab instance. Via the terminal, we'll do an ls minus ALR of runs. Okay, I might have the path a little different here. I just do ls minus, everybody remembers the command line options, ALR, long and recursive. So what has flown by here is the different, let's have a look, let's explore this a little bit. What are we seeing here? Version, okay, so we're doing recursively, we're going into the subfolders. So at the top level, we see the run from, go ahead.
I'm sorry, I was just clearing my throat. I didn't realize I'm on mute, but I can explain some of these.
Why don't you go ahead? Since
yeah. Well, I mean, we use internally, it's like a linking, hard linking model. So you can explore the version that was created before the run. And that's what the version subdirectory is. If you keep going down, the more interesting is the workspace subdirectory. And I'll note the most intuitive way to do this is if we mounted all these directories into Jupyter Lab as opposed to the workspace. That's something we need to do. So this is the main, is in that workspace directory. You now see your script, the run.sh, the environment YAML, the figure output, the standard error and standard out that have been captured, which would have been the same information that came out when you ran the script manually. And then that Docker stats will have some runtime statistics in terms of memory and CPU usage.
File Explorer, Craig?
You can't, the way Jupyter Lab, you can't browse up, which is an annoyance.
I cannot go to the parent. Okay, so we go through backdoor. We go through a terminal. Okay.
Yeah. So that's the whole point, is that you see that there's a immutable version plus the run itself references that version and then includes the outputs, which were not part of the original version of your code that was made.
We could create another run, right? We could run it again, and then we would see two runs, right? Maybe we change some parameters and we run it again, and we have a copy of that run too.
Correct.
Okay. All right, and we also see, for example, standard error and standard out. We can peek into that. Okay, hold on. At the bottom, so there should be CD runs, right? ls. Okay, CD. Then this long thing. ls. Wait, what? Okay. Now I got lost. Oh no, that's figures.
They're hidden because they have dot. So you need to do ls minus LA.
Sorry, say it again, Casper.
You just did what I said, so it's okay.
Oh, good. Okay, and so for example, we can look at standard out to see whether our recorded run can also do counting. Yeah, it can count from 0 to 95. Fantastic. And then I think there was a standard error, which is the deprecation warning or some such thing, which says, yeah, the color map. Yeah, okay.
So
Good.
one thing that you may try to do is try to remove a file from there.
Sorry, say again?
Try to remove a file from there.
Oh, try to remove a file from here. Okay, let's look at the file first. So any file here?
Any file.
Remove run.sh. How do you like that? Whoa, not permitted.
Yeah, so this is like both versions and runs file systems, they are read-only, like they're immutable. You cannot, they're preserving the history. So that's the point, that you cannot remove anything.
Can't mess with the history, right? Not easily anyways. Remove standard out. Nah, not permitted. Thank you, Casper. I did not know this. Very good. All right. And again, there's more instructions. Again, you see the material is so detailed. You can do this at your own leisure tonight. If you get bored, you can do it all over again. So there's concatenating, I mean, looking at the file. I think we've looked at these things now. The Docker stats, let's have a quick look. Docker stats is, I think, one level up. Is this correct? Oh, no, it was one level down. Okay. Sorry, I'm in workspace, right? My tab completion either doesn't work or I'm just not good at it. Where are the Docker? Oh, there it is. More Docker stats. Let's see what Docker can tell us here. Sorry, because of this resolution, the lines wrap around, make it a little hard to see. But it seems to be telling us something about maybe CPU usage, and memory usage, and so on. Yeah, you see that. There are multiple entries. Since I have the experts on, is this multiple sub jobs? Like, why are there so many entries? Or
because you have to pull, yeah, this isn't a particularly intuitive piece of information, but it's useful to know. It's basically polling Docker during the run points in time is the only way we can get the stats. So it shows over at different time points what's being used.
Good.
We will eventually summarize that in a cleaner way. So this isn't, it's nice to know it's there, but we don't need to look inside.
Right. So I think we've seen how to run a tail, how to do a recorded run. There's more information also here to do things for MATLAB and Stata users. But let's go to sharing, exporting, and publishing tails. Okay, there's some little hurdles or hoops that we have to jump through. So let's see how far we can get here. So now we want to share a tail with maybe specific users or with the world. So let's go through that. So from your tail, select the Share tab. Let's go back. Let's go to out of the Jupyter. This was the Jupyter Lab tab. Let's go back to the tail view, so to say, or the dashboard view. And now we want to share this. So there's a menu up here, Share. Do you see that? I'm going to move my mouse, circling closer, 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 Share. All right. So what are we supposed to do? Maybe we want to make it public. So we have two access modes here: private, the tail is visible only to you or other users you have explicitly shared it with. So when you say private, it means private and your friends, once you allow them to, or public, then it's read-only, accessible to the rest of the world. You can use the collaborator search box to search for the name of a collaborator. So for example, if I want to share it with, let's say, Craig, here we go. So these are, of course, users that have registered to the system. So once your collaborators are registered, you can select them and say, okay, do I want to allow Craig to view it? Well, I trust him. I allow him to edit, okay, the tail, because he can put all the, Craig, you can add Emacs later to the tail. Just kidding. All right. So what now? What do we do next? Let's see. Maybe we want to export the tail now, right? So that's exporting.
Just briefly, I think the point here is to talk about the permission models. So if you go up a section, there you go. So, and it's a little confusing. Someone who has view permission, whether it's public or whether you've shared privately with view, they have read-only access, but to be able to run the environment, we have to effectively create a copy. So that's what happens. So if you share something with view permissions to a user and they try to interact with it to run the instance, they're prompted to make a copy. So they can't modify yours, but they can make a copy of it, and then they effectively have right access to that copy. And there's just a subtle distinction between edit and ownership. Ownership is, it's maybe the more important, can actually delete versions and runs and delete the tail itself. Whereas if you just if he's given me edit permission, I can edit the metadata, I can create and delete folders and files, I can register data, but I can't delete the tail, I can't delete versions or runs. And so that's just the details of the permission model.
No, that's good, thank you. But I can I change, oh, hold on here. I can make you own this tail and do the even more powerful things.
Yeah, and you can reduce permissions and I'll get a notification, at least if I'm logged in, that says that I've lost access. So. Okay,
where do I say save now? Is this under this black thing here?
No, it actually does it automatically when you change the box. It's a little confusing.
I see.
So it's saved.
Okay. Yeah, and then notice that when you make your own copy, that's the one where sometimes upon first reading it sounds like maybe you've done something wrong. You cannot run this, so we make a copy. It's all good. We should put a happy face next to it, saying this is working as expected.
And okay. One other detailed point I'll just make is that no one ever shares a container instance. So even though Bertram and I can share access to the file system, when we run our instances, we're not sharing Jupyter Lab. We have our own instances of Jupyter Lab that are modifying the same file system is the way to look at it. And then you can move to the next activity.
Great. Okay, thank you. Let's export the tail and then publish the tail. And that's probably as far as we get. So exporting the tail means we're creating that research object that I told you so much about as a zip file, and it has all the good stuff in it. And publishing it means putting it in a repository for others to get it from there with a DOI and whatnot. So we'll try to see whether we can run through both. Let's export it first. Let's get it out. So we've created something inside of this wholesale environment. Let's take it home with us, yeah, on the hike. All right. So what are we doing? We go again to the little dots and say export. All right. Where is it? Export tail. And it is now telling us, all right, where do you want to save this wonderful tail? I'm going to put it again in my clinic subfolder. And then I'm going to look in that through my wonderful universal tool here, and hopefully it'll show up here. Okay, you see there's a zip file from 315. That's now. It has a unique name here apparently, and it's a zip file. So I'm going to just peek inside of that zip file just to get an idea what's in there. So of course you could unzip it, but I'm just going to be lazy here and just use my Emacs to look inside. And now this is in the way, so let me look here. So what's in there? Notice there is a LAN lab example Python file and the environment and the run file. These were the 3 files we first uploaded into the tail. But now, right, and they were uploaded into the workspace. You see this quite nicely here. Oops, I clicked too soon and too quickly. I mean, I can look at this Python file, but I don't want to. But then look, there's a runs subfolder, and look at that. In the runs subfolder, there is a Thursday, May, subfolder. And if we had multiple runs, there would be multiple of those directories. And then there's a copy of the file for this particular run, because maybe if you have multiple runs, we edit the file, and we want to know the exact version, right, of that at that point. So we have in the run folder a copy of the Python script that we ran, of the environment. We have the standard in and out, the standard out and the standard error, I think, with Docker stats, and with also, for example, the figures. Yeah. Then, of course, the tail contains other good stuff. There's baggage information. There's more on that in the tutorial notes. We'll not talk about it now, unless somebody wants to say something quickly. There's the license. Yeah, we talked about the license earlier. This work is licensed on the Creative Commons. Okay. And I guess this would also be the place for specialized licenses for special parts of the tail, if you like. I think that would probably go in here somewhere. All right, so this was the export feature. Let's do one more thing. So Wholetail uses an archival export format based on the Baggett and emerging research object standards. So again, as usual in life, there's different kinds of standards or conventions out there, and we're trying to follow those that that are popular and widely used. All right, and there's a link to a paper. Yeah, you can look at the details. Now let's publish a tail. So Wholetail allows you to easily publish or deposit, for example, to Zenodo or some of the Data1 member repositories. So in this example, we'll demonstrate publishing your example tail to Zenodo's sandbox environment. This step assumes a few things. So we'll see, keep your fingers crossed here, that you have a valid GitHub or ORCID login for access to Zenodo. So if you have a GitHub ID and or ORCID login, you're good. If not, you need to create one of those. So first you must connect Wholetail to Zenodo. Select the user menu, select settings. Okay, let's give this a try. Craig, we're going to move you around here. The user menu is in the upper right. Okay, remember I'm still in this incognito window that's all dark. But here on the upper right, it says user menu. I'm clicking on that. I'm logged in as me, and I'm going to click on settings. Aha. I'm already authorized. Maybe I'll disconnect and reconnect. Can I do this, Craig? Is that safe? Want me to do that?
Yeah, it's fine.
Let's say, are you sure you want to disconnect this Zenodo external account? You can choose to reconnect in the future, such as right now. Okay, so let's see what happens. So when you click on connect, it says, all right, which repository do you want? There's a sandbox for things that are sort of not meant to be in perpetuity, right? That's the real zenodo.org, and there's a sandbox. So we'll go to the sandbox. And now we need an API token to really make sure that we are, we are who we say we are and all of that. Let's get one from Zenodo. Okay, now comes the unpleasant part. So, right, now you need to demonstrate, I think, to Zenodo that you are who you claim you are, or just say who you are. And yeah. So I can log in with GitHub or with ORCID, or I guess you can create your own. This is a Zenodo account, I assume, that you can also set up. But let's try whether I can log in with my GitHub ID, sign in to GitHub to continue to Zenodo, right? All right, let's see. Life can be complicated. Let's see. Ludash, let's see. I don't know whether this is the right one. Keeping my fingers crossed. You're being redirected. Okay. So now I'm at Zenodo with my GitHub credentials. Okay, I'm still following along. I give this token a name. What is this Wholetail demo? How would we call this, Craig? What's your best guess of a name for this access token? Wholetail access.
muted. CSDMS demo or wholesale demo is just fine.
CSDMS demo. Yeah. And the scopes are, I think, allow publishing of uploads. Okay. Allow uploads, but not publishing. That sounds disjoint, but we'll click it all. Allow access to email addresses. Does that sound good?
Yes.
Okay, Ludish at Gmail. So this is my, for some reason, some GitHub ID that was used to authenticate. All right, now, this wonderful, uniquely created, oops, not this whole thing, this thing here, this access token is what I'm going to copy over so that Wholetail and Zenodo sort of have a trusted relationship. Let's put it this way. But did I forget to say save before? Do I have to click this again? I'm not sure.
No. They allow you just to revise those scopes. So just take the token you've got is fine. You don't need to do anything else.
Don't I have to say save here? No?
No, you've already got the token. So
I got the token. All right, so now where do I plug this in? Here. I plug this in here and I say connect. If all goes well, it says authorized. Okay. So now through Wholetail, I'm now authorized on the Zenodo sandbox, and we can follow these wonderful instructions. Next, confirm that you're accessing Sandbox Zenodo. Yes, we did that. At this point, you will need to log in. We did all of that. We created a token. Wonderful. All done. All done. It says this. This is exactly where we are. Now we go back to the tail dashboard and select view on your current running tail, and then we can do publish. Okay, let's go back to our dashboard view. Okay. I think we are there. Wait, what? I thought
click on the tail dashboard button or there. Yeah.
Oh, tail dashboard right here. Yeah. Okay, my tails. So my tail is running. This is example 3. And now I want to publish it. Right. So
click the view button in the middle when you're hovering.
Sorry, I need to, yeah, I need to go into the actual view. Okay. All right. And now over here, share. How about share?
No.
Wait, I have to wait first for the. Oh, share is.
Dot menu because you're publishing.
Of course, everything important is over here. Thank you. All right. Okay, publishing creates an immutable, notice the word immutable, copy of your tail with a DOI. For more information on publishing and citing your tail, please consult the publishing guide. Now, we had just a break, a little chat. Well, what if you publish something and then say, can I unpublish that? Well, that's not how it works. You can make an addendum, you can forward correct. If you publish it, it's published. And it's the whole point of an archive. It will be forever known as this version where you screwed up. Okay. So what? Right? This happens all the time. You say, sorry, there was a bug, we fixed it, and now it really works until the next bug is found. Okay? So what do we do here? Zenodo sandbox, we select that and we say publish. No, turning back now. At this point, the tail has been published to Zenodo sandbox. All right, here it is. And there is an identifier. We'll grab that. Let's say we copy the link address. Just for fun, we open a new tab, plug this wonderful thing in there, and wait for it. There it is. Okay. It has 0 views. It's not very popular yet. 0 downloads. It has a DOI. Okay. Luckily, we don't have to pay for that. And yeah. All right. Live demos are fun. Yeah. Okay. So I think we did all of that. So hopefully, did some of you go that far? Have you gone all the way to the end, to the bitter end? Yes. Timid nodding here. Plausible deniability. Very good. So you can share your tail within the Wholetail system. Other users can have read-only, edit, or ownership permissions. We talked about that. If your tail is public in Wholetail, all system users will have view access. At any time, you can export. Remember, you can take your tail on the road if you like. You can publish your tail to supported repositories. I just showed you that with Zenodo. And so you can also publish the exported tail to any repository outside of Wholetail. So if tomorrow you want to put it somewhere else. Now, how are we doing on time? there is a way to work with external data, but maybe we should leave the last 5 minutes for a little Q&A. And you tell me where to go. Where do you want to go from here? So in terms of, if we go back to the high level, let me just show you what else is in this tutorial. What some things took a little longer, but so here we have, we went up to this point. Working with externally registered data means just that you can say, you first identify a data set through, say, a URL or UI, somehow you get to it and say, register this. And then in the second step, it's a two-step process. And then the second step is sort of incorporated into the tail. And then unlike the other data sets that you might have explicitly put inside the tail, you have now an access through that reference mechanism. But it's all transparent, the system knows about it. And as part of the metadata, it is known, oh yeah, this tail uses that external source. Okay, that's important that this is documented and transparent. We can also work with MATLAB, so we have a license. So if all of you hit that at the same time, I don't know, there's sort of some limitation that I don't know what the exact number is, but you can, if you don't have a MATLAB license, you want to use it, you can use Wholetail and use it that way. And there's a final review, and then there's a questionnaire. I almost forgot the questionnaire. Do not leave this room. Do not proceed to the cookies and coffee. Please, if you have a few moments. To the review takeaways, you can do this yourself. Yeah, you don't need me for that. But let me just point you at the bottom. Yeah, this is at the bottom of the page here, post-clinic questionnaire. So we'd love to hear from you. And it's a simple Google form. Okay, I'll just read quickly the questions so you see that you're not afraid of this. So this tutorial was relevant to my work or my research. You can strongly disagree or agree or anywhere in between. I learned something about computational reproducibility or transparency. I'm likely to use Wholetail in my work. Is there any way we can improve our tutorial or training materials? Is there any way we can improve Wholetail to make it more useful or relevant to your work? Is there anything else you'd like to share with us about the tutorial or the platform? So please take a moment. I'm not going to look. It's probably anonymous, I assume. There's nowhere. Yeah. You can say what you like. And other than that, I want to give special thanks to Craig, who's created this material, and to Casper, who's developed much of the system, and for being here with me today virtually. And yeah, Casper is on the road. And any questions? You're all happy? Yes. Mm-hmm.
What's the current Wholetail computing resources? Does it support parallel computing?
Does it support parallel computing with the current resources? Well, it is a pretty generic virtual machine. So I don't know how many cores it has, but if you have Python code that uses multiple cores, then to the limited extent, I don't know what the physical machines right now are, but if you wanted a specialized high-end computing environment, we're currently connected to just these machines on Jetstream. So is there a particular parallel system that you're interested in? Just generally. Yeah. So Craig, do you want to say something about our parallel capabilities right now that Wholetail has in its
it's what you've said. Yeah. So we don't support, we'll hopefully go for additional funding to integrate with like actual clustered computing, distributed computing. But for now, it's just a VM. If you hit limitations, you're welcome to hit me on Slack, or get issues. It's parallelization within the context of a container on a VM. You can do it. We can expose more cores. We can increase the size of virtual machines to meet requirements, but it is just a single virtual machine.
Yeah, does that answer the question? Yeah, so it's whatever Jetstream resources we have allocated, but if you have specialized needs, then we don't have, say, support for specialized hardware at this point. But there's no fundamental reason that couldn't be done other than you have to have access to these resources, get the cycles and all of that. Yeah. Other questions? Yes.
What's the best way of using Wholetail when you're perhaps accessing a data server, for instance, and you're downloading small amounts via an API, or basically hotel where you don't necessarily control all of the services you're connected to.
Yeah. So what's the deal, so to say, with data that you cannot easily download all, or so there's
You may not have a license to be able to store that data locally in your.
Oh, you don't, yeah. So again, there is one way, that's exactly the part that we skipped, to excuse me, to register a data set and then use it through an API. Now, sorry, I lost a little track of the various tabs here. This is the wrong. Go ahead.
So what Bertram was about to show you is requires the data set to be publicly accessible from a provider that we integrate with or have HTTP access to. So if you're dealing with something licensed, you don't have a lot of options. Like your code has to access it as it would within the context of code published in a Git repo. If it's data that you don't cache cache locally, and it's pulled dynamic. Is it dynamic data that's also changing over time? Like you have to pull it via an API, and at a future date it may be different, because that's even worse, I think. So
I guess in this scenario, it wouldn't be changing. It should be the same data you should get if you're using the same parameters to pull it. But yeah, you're not necessarily allowed to republish it yourself.
Yeah, but with an access token, I mean, I think so. If I understand this problem correctly, what you could do is, you have your strip, you have your tail, and at some point when you actually want to access the data, you have to demonstrate that you are allowed to. And maybe at that point you would put in an access token, maybe in a similar way that I showed with this other use case with the Zenodo token that was created. So maybe that would be a way so that on the one hand, you can publish something, make it available, but unless you have that token, you can't actually run certain parts of the tail where you need access to the data. Yeah.
and that's it. So authentication is one thing, but let's say it's a public data set that's unchanging. You just don't have rights to redistribute. It's a nice feature of the recorded run is you can at least say, this is what was accessed to generate these maybe intermediate results on a particular day without redistributing the original data. If it's something that we can support via the HTTP registration, you can say, you cited it. We at least have a reference to it, and others can pull it in when they rerun their tail within whole tail. It gets a little complicated. But you would never include, that's the point of this registration feature, which is, it doesn't handle all cases, is to not include a copy of the data set in your tail. It pulls it dynamically when someone reruns it. So we have a caching mechanism on the back end that will go fetch from a source data set. So that would work in the case that it was something public that we could retrieve later on behalf of a second user, where you would effectively publish a citation that you used this data set, but not make a copy of it in your.
You have a record, you run your recorded run, you would have a record of the fact that in fact you used this particular reference URI, say here, yeah. Yeah. So again, yeah. So I tried this whole thing before, so this should also work for you. So you can try this part as well, but you just didn't get to it today. All right, good. And I hope that was useful, interesting. And again, if you have a chance to give us some feedback, a project team will be very happy to have your comments. All right, Albert, back to you.
Yeah, no, this was awesome. Really much appreciated that you're giving this demonstration, and also Greg for being here online. I think it's a break right now, and then we will.
So thanks, Craig, and I'll zoom you out now. I'll unzoom you.
All right, thank you.
Thanks a ton.
Yes.
This worked wonderfully. Thank you, Craig.
Catch you later. Yep.
Bye.